Hello everyone, I welcome you all in the second lecture on topic simple and compound interest, where we are going to understand how actually compound interest works. And also we are going to see why compound interest is different from simple interest. So we are going to learn the salient features of compound interest in this particular lecture. Towards the end of lecture, I'm going to show you an elegant way of solving the questions of compound interest. So please make sure you do watch the session till the end completely. So that's the agenda. Let us start the session now. Now, before I discuss the calculation of compound interest to you, I want you to understand that simple and compound interest are just ways of calculating interest. It's just that compound interest is a little different from simple interest, and that is what we are going to look at when I do the calculation by using the data which you can see on your screen. So principal is 1000, rate is 10% per annum at compound interest. And here you will find a new term, compounded annually. What does compounded means? Now, this term compounded is something which changes the whole calculation of compound interest. So compounded simply means update the principal. And when I read the two words together, compounded annually, it means update the principal. Annually means at the end of year. And this is something which is very crucial when it comes to the calculation of compound interest. So for the same number of years, means for 3 years, let's see the calculation of compound interest. So for first year, if I ask you what is the amount kept at the start of year, you would say, sir, we just have rupees 1000. So 1000 is the amount which I have kept at the start of first year. Once the year will end, I need to calculate interest. How much? 10% of the principal, 1000. That will be 100 rupees. So what will be the amount due to me at the end of year? You would say principal plus the interest. And this will return me the value of amount 1100. So I hope this much is understood. Now in second year, if I ask you the value of principal, many of you would say, sir, it's 1000. In case of SI, this is what we have learned. In case of simple interest, the value of principal never changes. And with this logic, you would say, okay, sir, principal value should be 1000. But this is what you have to understand. In compound interest, compound actually means update the principal. Update the principal at the end of 1 year. Since 1 year has ended, so the principal value can never be 1000. It has to be different from 1000. Since now I have a total of 1100 rupees which I have kept here. So instead of 1000, my principal is going to be 1100, right? Update the principal at the end of 1 year. So whatever is the value of sum at the end of 1 year, that is going to be my new principal in the next period. Now, when it comes to interest calculation, again, you are going to calculate R% of the principal. Now, the new principal is 1100. 10% of 1100 is 110. So what would be the value of amount at the end of second year? You would say, sir, it would be 1100, which is the new principal, plus 110, the interest earned on this principal. And when you add the two, you will get 1210. That will be the amount due to you at the end of second year. Again, since 1 year has ended, again, for the next period, I have to update the principal. Now, in third year, if I ask you what is the value of principal, is it going to be 1000? No. Is it going to be 1100? No. Since we are dealing with compound interest, compound means update the principal at the end of 1 year. So again, after the end of one more year, the amount changes to 1210, and therefore the principal value in third year is going to be 1210. And again, to calculate interest, I'll calculate 10% of 1210, which is nothing but 121. So what will be the amount due to me at the end of third year? Very easy. You would say principal is 1210. Simply add 121 and you will get 1331 as the total interest which is payable to me at the end of 3 years. Okay. Another thing which I want you to realize, I hope most of us are already aware, the way we calculate compound interest using the formula. So in the formula, we have the same variables as in the case of simple interest. It's just that the formula is different here. To calculate amount, the formula in CI is P1 plus R by 100 to the power n. Again, you'd realize that the terms are same. P is principal, R is rate, we know A, amount, N. For now, you can understand n as the total number of years. Although it is different, I'll talk about it later. But for now, let's say n as the number of years. Another thing that you have to realize is, in case of simple interest, when I use these factors P, R, and T, when I multiply the three, I get the value of interest. But in case of compound interest, when I use these factors, principal, rate, and time, I get the value of amount, not the value of interest. So this is how compound interest is different. In fact, in case of compound interest, if I have to find out the value of interest, I have to remove the value of principal from amount. So this is how we calculate compound interest in case of CI. Now, once you are aware about this formula, now I want you to apply this formula for the 3 years. Okay, I want you to cross verify whether the formula is giving me the same value of amount or not. So let's apply it for the first year. For the first year, in order to calculate the value of amount, principal value is 1000. So let's write 1000. 1 plus R, rate is 10. 10 by 100 to the power what? Since I'm doing calculation for 1 year, so power is going to be 1. Once you simplify this, you realize that this is same as writing 110 by 100. And when you do the calculation, you will get 1100 as the value of amount, which is exactly same. Compare. Here I'm getting 1100. Here also it was 1100. So the formula will not fetch you out a different answer. It will give you the same answer. Okay, let us apply this formula again to find out the interest at the end of second year. Now for the second year, if I ask you the value of principal, you would say, sir, now the value of principal is changed. It's 1100 now. In place of principal, write 1100. Again, since rate is 10%, so it's going to be 110 by 100. And for how many years? I want to do calculation again for one more year. Okay, so power is going to be 1. And once you do so, you will get 1100 into 110 by 100. This will return you the same answer of amount 1210. Let's apply it again. Amount. Now, what is the value of new principal? It is 1210. Okay. 1210 into 110 by 100. Since I want to do the calculation for 1 year only, right? So simply multiply, and again you will get the same answer 1331. Now, through this, I just want you to realize that we are not doing something which is different from what we are already aware about. We already aware about the formula of amount in case of compound interest. So using the same, I will reach to the same answers, right? We are not doing anything different here. But the way I'm doing it, it is a bit mechanical, isn't it? And therefore, let me give you a better approach, a visual approach using which you can do the same calculation, but in an elegant manner. Now, before I show you the visual approach, I want to show you something which is very important, which is an important learning which you should have by looking at this table. If you look at the table carefully, one thing that you should note down is simply look at the principal values. If you look at the principal values, right, for any 1 year, yes, right, you realize that the principal values are changing. Likewise, if you look at the interest value, the interest values are also not same. In fact, the values of interest are increasing year by year. This is something which I want you to note down. Unlike in the case of simple interest, where the values of interest remain same for any 1 year, for any given year, you realize here the same thing is not happening. Compound interest in the first year was 100, in the second year it is 110, while in third year it is 121. So the learning which we had in the case of simple interest, it is not applicable in the case of compound interest. So these are some important points which I want you to keep on your mind. Okay, and now let me show you the visual approach using which you can do all this calculation in a very easy manner. And for that, let me use the same data which we had used in the previous question. Principal is 1000, rate 10% per annum at compound interest. The important term is compounded annually. It means I need to update the principal after every 1 year. Okay, so I'll start with this amount. This is the amount which I have deposited. And then what is going to happen? I'm going to get R percent, right? I'm going to get R percent of what? R percent of principal. R percent means 10% of what principal? The amount which I am starting off with. So I have started with 1000. So this is my principal. When you do the calculation, you'll get 100. So what will be the amount at the end of 1 year? It will be 1100. 100, the interest plus principal will give you the value of amount. Now again, for the next year, I have to calculate R percent of the principal. Now the important point here to note down is, while you calculate 10%, here you are going to calculate 10% of the new principal. The new principal is 1100. So you'll not calculate 10% of, this value. You'll calculate 10% of 1100, and that would be 110. So simply add this interest to the new principal value and you'll get the amount at the end of second year. Let's do this calculation one more time. Again, you'll calculate R percent of P, and I hope by now you have understood that I'll be calculating R percent of this updated principal, that is 1210. So what is 10% of 1210? It is 121. And now to find out the amount at the end of third year, what I'm going to do, I'm going to add 121 to 1210. That will return me the amount as 1331, the same answer, right? Another thing which I want you to focus upon, if I call these three values of interest as I1, I2, and I3, I1 is 100, I2 is 110, and I3 is 121. So these are the three values of interest in the consecutive periods. If you look at the interest values, and if I ask you from where did you get this, you would say, sir, this I1 is actually 10% of the principal value. This value I2 is 10% of this principal, and value I3 is 10% of 1210. So can I say that this is same as increasing a number by 10% successively three times? See, what I'm doing here, I'm calculating 10% of a number. What I'm doing then, I'm adding this number to this, and then I'm reaching to the other value. Again, I'm calculating 10% of this value, then I'm adding this, and then I'm reaching to this value. Again, we are calculating 10% of this number, and this in turns, when I add this to this number, we are reaching to 1331. This is same as increasing a number by 10% successively three times. And the moment I look at this situation in this manner, the same question, doing same question becomes very easy. Now it has become a percentage setup where I'm trying to increase a number successively three times by 10%, right? So you can see that the changes which we are doing here, the changes are happening one after another. So these are successive changes, and we know how to deal with successive case. Now, in order to reach here, now what I can do, I can use multiplication factor in order to reach at this point. I already know what is the base value. So we'll start with the base value, and then we'll convert these percentage changes, 10%, 10%, these three changes in the form of multiplication factor. So tell me one thing, if I increase something by 10%, what will be the multiplication factor? You would say, sir, since you are increasing a number by 10%, multiplication factor is going to be 110 by 100, something which we have already learned in the topic of percentage. So it means I am going to multiply the base value by this number, right? Although I can write 110 by 100 here, but since I'm generalizing it, so let me write down multiplication factor 1. For the second operation also, I'm going to write down the multiplication factor. So let me denote it by multiplication factor 2. And then for the third change, again, I'll multiply this with multiplication factor 3. And this in turns will give you the answer of this point. I'll reach to the final value. Let's call this point as final value. So if I apply this, so what is your base value? Your base value is 1000. What is the multiplication factor for the first change? If I increase something by 10%, multiplication factor is going to be 110 by 100. Can I rewrite 110 by 100 as 11 by 10? Now, if you look at this thing carefully, since I'm increasing my number every time by 10%, so can I say that the value of multiplication factor would remain same for the next two operations as well? So just multiply this by 11 by 10 three times. So zeros will get cancelled, right? We'll cancel the zeros. And now to answer your question, what is the final value? 11 cube. What is 11 cube? 1331. At least at this stage, you should know that 11 cube is 1331. So what is this value at this point? It is 1331. So can you see that without indulging into this thing, without indulging into any table, I can answer my question once I realize that compound interest is an application of successive percentage change. And this is the approach which I was talking about. Okay, so from now on, whenever I get a question of compound interest, I try solving it using the concept of successive percentage change. Now, to give you some confidence, how you can use this visual approach to find out the answers based on compound interest, let me show you one question. Please read the question once. A bank charges a rate of interest of 10% compounded annually. Now, these two words are very important. What is the total amount to be paid on a loan of rupees 36,000 for 2 years? Now, the first thing that you should notice, since they have mentioned I need to do compounding on annual basis, it means we have to update the principal at the end of a year. This is one thing. Since I have taken a loan of rupees 36,000, can I say that this is my principal? So it means my base value is 36,000. Your base value is nothing but the value of principal, the amount which you have borrowed. And now what they are saying, what amount you have to pay back in order to clear this loan of 36,000 in the duration of 2 years. So tell me one thing, since time duration is 2 years and the compounding is going to be done annually, means the principal is going to be changed after the end of every year. So in duration of 2 years, how many compounding periods? You would say, sir, there are going to be two compounding periods, 1 and 2. Since compound interest is an application of successive percentage change, so I can show these two periods in the form of successive cycles, right? What is the rate of interest? Rate of interest is 10% per annum. Now, what rate I'm going to charge in this period? It's going to be 10% only. You know why? Because 10% per annum says that the rate is going to be 10% at the end of 1 year. Since the length of this cycle is 1 year only, so the rate is going to be 10% only. For the next period also, that rate is going to be same. It's going to be 10%. Now please focus. I want to find out the value at this point. So from here, how can you reach here? You would say, sir, I'll apply successive. Let's see how. What is the base value? Base value is 36,000. Then what is the operation? The operation is I have to increase this number first by 10%. And if you look at the second operation as well, it is also an increment of 10%. So whatever is the multiplication factor for the first operation. So multiplication factor for the first operation would be 110 by 100. So I'm going to write it 2 times. Why? Because there are 2 periods. And after doing so, I'll be able to reach at this point. I'll be able to find out the loan amount. Okay, let's do the calculation. It's very easy. This 0 will cancel this 0. This 0 will cancel this 0. These two zeros can be cancelled with these two zeros. So now all I need to do is I have to multiply these three numbers, 360 into 11 into 11. Let me do one thing. Let me keep aside 0 because I know that 0 will be the last digit of the answer. Now I'll just focus on multiplying. Multiplying a number with 11 is the most easiest task. How would you multiply? You'll start with the unit digit number. Start with 6. So just write down 6. After that, you have to make pair of two digits. So make a pair of two digits and add the values. 3 and 6 is 9. Try to make another pair of two digits. You would say, sir, we don't have any other digit using which I can make a different pair. And because of this, you'll stop at 3. Write down 3 here. So it is 36 into 11, it is 396. Again, we have to multiply this number 396 with 11. So let's see this, how this rule works. So it is the first step that will start with the unit digit. So write down 6 as it is. And then I'll start making pair of two digits as much as we can. Make a pair of two digits. Add the values. 9 plus 6 is 15. You get a carryover 1. 3 and 9, I can make one more pair. 3 and 9 is 12. Add this carryover. 12 plus 1, 13. Again, you will get a carryover of 1. Can you make another pair of two digits? No. And therefore, you have to stop at the final digit from the left, which is 3. And what is 3 plus this carryover 1? You would say 4. So after multiplying 396 by 11, you will get 4356. So just write down 4356 here. And we have a 0 at the end. So let me write down 0. So this will be the loan amount which you have to pay back at compound interest. So I hope through this question, you were able to understand how I can solve the question of compound interest very elegantly using the concept of successive percentage change. So with this, let's end this lecture here only. I hope you were able to understand things, whatever I have discussed with you today. If not, please write down your query in the comment box. In the next lecture, we are going to look at more important things which one has to learn in the case of compound interest. Not only this, we are also going to discuss different types of questions which can be asked in simple and compound interest. So stay tuned. Thank you and have a nice day.